Like, okay, I don't know. Like what would a piecewise function or a step function look like? Well, I would imagine one of them would be in pieces and the other one would have steps in it, right? Absolute values, we know what those are, but what do they look like in the form of a function? We're going to talk about that. But embedded in those ideas is the fact that I could take the absolute value of x, like you see in some of these problems, or I could take the absolute value of x squared minus 2x plus 1, right? In which case I'm dealing with a quadratic, right? So all those concepts related to quadratics could come back, and you need to be prepared for it. So you want to constantly be reviewing all that the previous time, all right? I've been holding on to your package just for safekeeping, but like I mentioned, and I think after every unit, if you ever want them back, that's why I have them here, so that you can't, well, I don't want to say you can't say, but so you don't have to deal with, I was looking for unit 2, I looked all over my house and I couldn't find it, right? So that's why I keep it here, so that if anybody's going to lose it, it'll be me. In worst case scenario, I'll just print you up a completed copy of my notes.
If we take them home, will you want them all back in here?
No, because I've already checked them off, but you should then be responsible for them all, so when we start reviewing, you have them all on hand. So, anyway, absolute values, pretty straightforward. Generally, numerically, it means that you're dropping a negative sign, but it really means more than that in terms of a graph. When we say the absolute value of a number, we're talking about the distance from 0 on a number line, right? So how far that number is away from 0. That gets a little trickier when you incorporate a y-axis, because here we're only looking at an x-axis. And we'll start with that, because in the cases of all these equations, we're working in one variable, just x. We're not including y yet, all right? So everything should be, in terms of a solution, on a number line, all right? So what do you do in terms of a process? You isolate the expression contained within the absolute value. Let me just move it over. All right, so isolate the expression contained within the absolute value. All right, so number 1 is good to go for that first step. Number 2, we'd have to move that negative 3 over. I want the absolute value expression all by itself. All right. Then what we do is take the expression that is within the absolute value. So I'm going to say take that expression. And set equal to plus or minus whatever is on the right-hand side. Because I'm assuming we're moving the variable in the absolute value, we're moving that to the left. All right. So make a note. If I like to use the abbreviations LHS and RHS for left-hand side and right-hand side. If you're worried that you're going to look back on your notes later on and say, I don't know what that means, write a little note to yourself right now, RHS, right-hand side. I don't think you would then have to write that LHS means left-hand side. That should be common sense at that point, but don't take any chances if you're worried. All right? And then the last step would be to solve and check. Solve and check. Right? It's kind of, I don't know, sometimes when I write a process, even ones I get from a textbook, like a well-regarded resource, sometimes the process seems very much like, all right, how to bake a cake. Step 1, get ingredients. Step 2, bake the cake. You know, it's like, yeah, there's a process, but it didn't really tell you anything. You know, this last part here, solve and check, it doesn't seem like it's telling you anything until you reflect upon all the different ways that we've learned to solve within this course. One way involves quadratics, and that's broken up into different categories, factoring, completing the square quadratic formula. Right? If it's a simple linear equation, it's just a matter of getting x alone. Right? So it could be very easy, or it could be a little bit more complicated. And then also on top of that, there's something that you have to never lose sight of, and it's ongoing. It's happening repeatedly when you get your tests back. Not today, because still people have to take it, but you'll get your grades. When you do look at your test, you're going to see that a good number of you lost significant credit in the multiple choice section. Again, how did that happen? Well, when there is a question that asks you which of the following equations, blah, 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 and then the choices involve the vertex, why anybody was writing down anything other than the final answer was beyond me. Like, you could do your negative b over 2a. You could put it in vertex. It's a multiple choice question. Type in the equation, hit second graph. The vertex is there. If it's not, then maybe you have to do the work, but those aren't the problems I put in the multiple choice. I put them so that you could find them in the table. I was being generous. So some folks took my generosity, crumbled it up into a big ball, lit it on fire, and then threw it back in my face. So, yeah, you got to be careful about things like that. The calculator is your best friend. I warned you about this a week prior to the test. I said, if you were not using the calculator the way you should be, you're going to run out of time. All right? You need to be able to use a calculator. Why am I saying this? It says solve and check. Solve each equation. Does it say algebraically?
No.
No. Solve it any way that you can. All right? You need to come up with a solution. Sometimes they're simple and you don't need a calculator. Sometimes a calculator is your best friend. All right? So, for these kind of questions, it's always your best friend. Never leave home without it. All right? So, isolate the absolute value, check. Take that expression, so that expression is the thing that's contained within the absolute value, and set it equal to plus or minus whatever the right-hand side is, in this case 4, plus or minus that. That is a whole lot of space for that, because that's the final answer. Because x is equal to plus or minus 4. All right. The next one, you're going to do a little bit more. Still don't need as much space as we're given, so somebody wants that as a typo. So here I want to add 3 to both sides. Take whatever's within your absolute value, set it equal to plus or minus whatever is on the right-hand side. X is equal to plus or minus 7. All right. Now, these kind of questions call for a number line answer. All right. Not so much for the equalities, but when we get to inequalities, we'll need to include those. So it's a good habit to get into now. And it has happened. They have asked about number lines related to this context before, so in reality, I'm just trying to justify all this space. All right, you need a reasonable scale and the numbers that are relevant included. So all I'm going to do is plot a point above or on the number line. It's up to you. I guess most people like to do it on the number line, so I'll do it that way. At -4 and +4. And then the same thing for the other one is going to be plus or minus 7, so same number line, essentially. Plot a couple of points. And again, just rough it out. It's nothing, doesn't have to be pretty. I mean, mine are gorgeous, but. All right, numbers 3 and 4 require a little bit more, but not much more. I mean, we're not really going crazy here. With inequalities, it can get a little tricky, but we're not at inequalities yet. So let's enjoy this while we can. Take whatever is within the absolute value and set it equal to plus or minus the right-hand side. All right, so I'm going to add 2. And so we get something that looks kind of like quadratic formula-ish. X equals 2 plus or minus 8. You can't just leave it like that. You got to figure out what they are. 2 minus 8, negative 6. 2 plus 8 is 10. All right, so here it's X is negative 6 or 10. Because you can't be negative 6 and 10 at the same time. So the nice way of writing your notation, your solution, is this way. All right, number line. Lots of points. And again, as long as your scale matches up, it's fine. All right, what do I do in number 4? What's my first move? Divide by 4. So I'm looking at absolute x plus 2 equals 5. Next move? Plus or minus 5 on the right-hand side. What's on the left? Just a clean x plus 2. Next move? Subtract the 2. So x equals negative 2 plus or minus 5. And what are my solutions? 3 and negative 7. So we'll do the negative 7 one first. Not a big deal either way, but wherever possible, increasing order is preferred. All right, so 6, 5, 4, 3, 2, 1, 0. 1, 2, 3. Pull out a move. And there it is.